we've seen what kind of influence factors we have on capacitors and specifically on the energy stored in a capacitor. So starting from such kind of system here, let's think about how we can increase the energy stored in a capacitor. Well, the first way to increase it, if we look in our formula, would, for example, be to increase the voltage, because the voltage has a squared contribution in here. So E is directly proportional to U to the power of 2. This means a greater voltage will give us a greater energy storage. Another way is to increase the relative permittivity. We've just seen that the relative permittivity of this medium in between the two plates can be very much different depending if you have, for example, air or if you have something like water. So in choosing water except air, for example, you can increase the relative permittivity by around 80 times. Now, the next factor to keep in mind is the D here. So E is inversely proportional to the D. This means if we reduce the distance between our two plates, we will also get a greater energy storage. And lastly, we do have the A, which is the area of our electrodes. So the bigger the area of our electrode gets, the energy stored in the capacitor will grow with it in a proportional way. Going from the concept of a capacitor to a supercapacitor will have certain advantages. And I first of all would like to introduce you what a supercapacitor actually does compared to one of these conventional capacitors. So the geometry of the capacitor, as we've already seen, puts a very fixed limitation on conventional capacitors, and there's very little innovation possible. You've seen that you can play around a bit with size of the electrodes, distance between them, and with the media in between. But other than that, there's not really much room to play around. So in a capacitor, we have a setup which is an electrode, a dielectric, and an electrode, and you will get a capacitance, and this capacitance will be 100% of the overall capacitance of this material. Now, if we go to a supercapacitor, we do have a somewhat more complex setup. We do have an electrode, a dielectric, and something what I call electrolyte here in between, another dielectric, and another electrode. Electrolyte can be any kind of solution, for example, which has ions dissolved in it. So let's say, for example, you put some table salt in water. So this is, in chemical terms, considered an electrolyte. For these supercapacitors, we have something called the double layer capacitance, which makes up for around 90% of the overall capacitance. And we have something called pseudocapacitance, which makes up for another 10% of the overall capacitance. These supercapacitors now can achieve significantly higher overall capacitance values than conventional capacitors. Well, for this